quick, graph one period of y equals 5/2 times the cosine of the quantity pi over 3 times x plus pi minus 1 by hand. This is part of the family of functions series. You will need paper and a straight edge, or you can download this PDF and print it. Press pause as needed anytime during this video. We want to graph one period, so we need to analyze this, that is, look at all the parameters and how they affect the graph. Which parameters affect the y values? We'll look at those first. It turns out the 5/2 times and the minus 1 outside the function affect the y values. So 5/2 times will multiply each y value by 5/2. Minus 1 will subtract 1 from each y value. And recall that by the order of operations, we multiply first and then add second. And we're going to apply this to the y values of the points of interest. So a maximum, which is normally at y equals 1, will be multiplied by 5/2 and subtract 1. So that would be 5/2, and we'll think of the 1 as 2/2. So 5/2 minus 2/2 is 3/2. Points of inflection lie along the line y equals 0 normally. Multiply that by 5/2 and subtract 1, and we get minus 1, negative 1 rather. And the minimum, normally at y equals negative 1, multiply that by 5/2 and subtract 1, would be negative 5/2 minus 2/2 would be negative 7/2. So we'll collect these down here, a quick summary of those key points of interest, the y values. So which parameters affect the x values? Those would be the ones inside the argument, the pi over 3 times and the plus pi. Those are inside the function. The beginning of a period normally starts at x equals 0. So what we're going to do is set the argument equal to 0 and solve for x to see where this one starts. So go ahead and solve this equation. Pause as needed. First thing I would do is multiply through by 3 to clear out any fractions. And that will leave me with pi x plus 3 pi equals 0. Subtract 3 pi from both sides and then divide both sides by pi. And you get x equals negative 3. Notice that is negative 3, not negative 3 pi. And so this one will begin at x equals negative 3. The end of the period normally ends at x equals 2 pi. We're going to do the same thing and set that argument equal to 2 pi and solve for x. Pause is needed. Again, I multiply both sides by 3. Got pi x plus 3 pi equals 6 pi. Subtract 3 pi from both sides and divide both sides by pi and get x equals positive 3. Notice it's positive 3, not 3 pi. And that's where the first period will end. Start at negative 3, end at positive 3. So using all these values, we need to decide how to mark the units along the axes. So pause to do that. So we're suggesting you mark every 1 unit along the x-axis and at least go from negative 4 to positive 4. On the y-axis, we think you should show every half unit and maybe go down to negative 4 and up to positive 2. Pause to do that. So you can see mine goes from negative 4 to 4 and from negative 4 to 2 and showing every half unit along the y-axis. So now we need to put all of these facts together. And so what I suggest doing is drawing dotted horizontal lines along the y values of the points of interest. So the maximum is along y equals 3/2. The points of inflection are along the line y equals negative 1. And the minimum is along the horizontal line y equals negative 3.5. Using the graph of the cosine, we start at a maximum, normally at 0, 1. But for our graph, it starts at -3, and our maximum is 3/2. So -3, 3/2 is plotted. That's our first point. At the end of the period, normally at 2 pi 0, for us the end of the period is at +3 and back up to the maximum of 3/2. So we'll plot that right here. Halfway between those 2 points is a minimum, normally at pi -1. For our purposes, it's going to be at 0 is halfway between, and the minimum is at -7/2. So let's go ahead and plot 0, -7/2 right here. Halfway between the max and the minimum is a point of inflection, normally at pi/2, 0, but for our purposes, halfway between -3 and 0 is -1.5, and it's down here along this line here. So -3/2, -1 is this point of inflection here. And halfway between the min up to the maximum is another point of inflection, and that's going to be at +3/2, halfway between here, and again along the -1 line. Pause is needed. Connect the points as a cosine wave. Be concave down, concave up, and half of a frown concave down. And here's that beautiful cosine wave, a little bit more than a period. Equivalent forms, just to check it. So I factored out the pi/3 inside the argument, and this tells me this is a phase shift to the left, 3 units, and let's check it on our graph, and it is. At -3, it started the cosine right there at a maximum. The period is inversely proportional to this, so I'm going to multiply 2 pi times 3/pi and get 6, and that is the period from -3 to +3 is a period of 6, so that double checks. Now you try one. Graph one period of this function right here. Hint, you will need to change the units. And remember, on the next page, we only give you the answer. So give me your best shot. Pause is needed. So here we do show the max, points of inflection, and minimum, where they occur and why, where the beginning and end of the period are, and we plotted them with the colors so you can kind of check your answers with ours.